Hello, today we are going to start our work formally in algebra, and we're going to look at something called variables and constants. A variable means something that can vary, which is a word that means change, and constant means something that stays the same, that doesn't change. So we're going to look at maths now involving things that can change and maths that involves things that can't. Now so far we've always been doing maths with constants. We've been doing maths with things that don't change. So this is the type of maths we're familiar with, and we're now going to be dealing with situations where we have things that can vary, that can change. To do that, I'm going to give you an example of an argument. And this is why we want variables a lot of the time. It's so that we can make arguments, so that we can try to explain things in more detail using mathematical language. So let's get into it. We want to know the cost of 3 Mars bars, 4 Snickers and a Twix. Now this is it. This is a question written out in English. What I want to do is translate this into mathematical language. How would that question look if we wrote it mathematically, if we wrote it algebraically? Well, there are a bunch of different rules that we have for writing things in mathematical language, but one of the core things is we want to write things as short as possible. So instead of having to write 3 Mars bars, I have a shorter way of writing 3. It's just the number 3. And how would I write Mars bars shorter? Well, I could just say either Mars bars or specifically the cost of a Mars bar could be written as M. So the cost of a Mars bar, M for Mars bar, is going to be written as M. And I want to know the cost not only of the 3 Mars bars, I want to know the cost of 4 Snickers as well. Well, how do we do as well in mathematics? We'd add those things together. If we wanted to know 3 Mars bars, 4 Snickers and a Twix, we'd have the cost of this plus the cost of this plus the cost of this. So we would add them together. And 4 Snickers, well, 4 is just 4. Snickers, what would we use for that? Well, S is a sensible letter for Snickers bars. And then we have a Twix. Well, how many Twix is a Twix? It would be 1 Twix bar. But just like in English, where we don't tend to write 1 Twix, we tend to write a Twix. Instead of writing 1 T for 1 Twix, we tend to just write T for a Twix or for 1 Twix. You won't lose marks for putting in a 1 here, but in general we don't write it that way. We would just write T for Twix. So I'm going to remove that there. We're going to have just T for Twix. So what we've done is translate this fairly long English sentence into a very short mathematical sentence. But to do it, we've had to use a few rules that I have slightly glossed over. I've talked about one of them specifically. If we have 1 of something, we tend to just write the letter. So a Twix or 1 Twix would just be written as T for Twix. And as I have written the other letters in lowercase, I will write that as small case t as well. So uppercase and lowercase letters will mean different things in algebra. So if we're given a small letter M, we have to use small letter m. If we were given a capital letter M, we'd have to use capital letter M. So we have to be careful not to mix up uppercase and lowercase letters in algebra. Now, I've said that 3 Mars bars would be written as 3M. What does that mean mathematically, though? This makes a certain amount of sense in English, but what have I effectively done? What I've done is effectively say that if I have 2 things sitting next to each other, they are multiplied. 3M would mean whatever the cost of 1 Mars bar is, multiplied by 3 to get 3 times that cost. So letters sitting next to each other are multiplied. This is one of our key important features in algebra, and it saves us having to write brackets around everything all of the time. We'll write brackets a lot for multiply in algebra, but we won't do it all of the time. We'll try to avoid it if we can, because it gets annoying to have to keep rewriting brackets over and over again. So instead of having to write in my blue brackets here, I would just be able to see I had 3 M's, 3 costs of a Mars bar, plus 4 costs of a Snickers bar, plus 1 cost of a Twix. If I found out what a Mars, a Snickers and a Twix cost in a particular shop, I could add all of that up and find out what the cost of my chocolate bars would be in total. So let's take an example. Let's say we go to our local shop and a Mars bar costs €1. A Snickers bar, we'll say it's a big Snickers bar, might cost $1.50. And we'll say that a Twix costs €2. Again, we can say it's a large Twix if you like. So I now know what the values are for my Mars bar cost, my Snickers cost, and my Twix cost. So what I can do is, in place of my letters, I can now put the numbers that I know for it. So this is shop 1. We'll say this is the first shop we go into. And this is the costs for shop 1. And I put in then, well, the cost of each Mars bar is €1. And the cost of each Snickers bar is $1.50. And the cost of my 1 Twix bar is going to be €2. Now, what can we see that I've done here? Around each of my numbers that I've substituted in, I have put brackets. And this is going to be very important for not making mistakes in the long run. Anytime we make a substitution into any kind of equation or formula, we'll learn about them later, we are always going to put everything we sub in inside brackets. Now, this is a sum we already know how to solve. This isn't any problem to us. Now that we've put in our numbers, this is just what we already know. 3 by 1 is 3. We can check on our calculators, or we can work out that 4 by 1.5 or 150 is going to be €6. And 2 multiplied by plus is just going to be e plus 2. And now I can add all of that up and I will get €11. So the total cost of buying my chocolate bars in the first shop is going to be €11. But I could say that I go into a bargain shop somewhere else, and I find that my Mars bars here only cost me 50 cents. They cost me 50 cents, which would be 0.5 of a euro. My Snickers bars only cost me €1. And my Twix bars only cost me €1. So now when I put that in, I still have my original formula. I want 3 Mars bars, 4 Snickers, and 1 Twix. I have 3 by 0.5 plus 4 Snickers, which each cost me €1, plus a Twix, 1 Twix, which just cost me €1. Again, we're now back to what we already know quite well. We're able to multiply that out. We're going to get 150. For our Mars bars, we're going to get €4 for our Snickers bars, and we're going to get €1 for our Twix. And when we add all of that up together, you're going to get €6.50. Now, what are we doing here? Well, we've got terms, is what we call these things here. Each one of these is terms, and we've got stuff that changes. The cost can change depending on the shop that we're going into, but the amount of each bar that we want is staying constant. So if I take my 3M for the cost of 3 Mars bars, my 3 here doesn't change, it's a constant. And the M can change. It changes depending on the shop we go into. The cost of the Mars bar changes depending on the shop we're in, so it varies. It is a variable. So this is what we mean by constants and variables. Things that don't change are called constants, and things that can change are called variables. Depending on which shop we go into, our chocolate bars cost a different amount, but regardless of which shop we go into, we want the same amount of each bar, so that the amounts of bars that we want would be constant. Now, so we've seen that letters and numbers sitting next to each other are multiplied. We have a letter by itself means one of that letter. We know that the numbers we're dealing with are called constants, and we know that the letters we're dealing with can change, so we call them variables. That is what we need in terms of our language. The last thing I'm going to mention is that if we can only add up variables of the same type, but we're going to deal with that in more detail later on. Now, let's put some examples in here that have less context than my initial example. The difference between 12k and 7or. Well, what does difference mean? It means subtract. So writing that mathematically, this whole sentence becomes 12k minus 7or, because difference means minus two things. In this example, what is half of 6 times m, where m is some variable, it's something that can change, just like m was the cost of a Mars bar before. So half of 6 times, so half of means multiply, 6 times means multiply, and I have half of 6 is going to be 3, and I still have it multiplied by m, so I have 3 multiplied by m, I can just write as 3m. Now sometimes, just like in my example here, I will find out what my letters are equal to. So if I have a squared minus 3 plus b, and I know that a is 2 and b is minus 6, I can substitute in just like I did for my costs here. So I put everything in brackets when I'm doing a substitution. So a is 2 squared in brackets minus 3 plus minus 6 in brackets for my b. Now I go back to BIMDAS, and I'm going to follow BIMDAS anytime I'm doing a substitution. So I have 2 squared, it's going to be 4 minus 3 plus minus 6. And I have 4 minus 3, I do my multiply next, it's going to be minus 6. Then I do my adding, and I get 4 minus 3. I can put brackets around this to keep track of which I'm going to do first. So 4 minus 3 is going to leave me at 1 minus 6. And then I'm going to do plus 1 minus 6 ends up at minus 5. And that's my final answer. And it's extremely important that we show each of our steps as we're going on down, or we won't be able to do our algebra in the long run. Finally, we have x is 1 and y is minus 2, and I have this division going on here. So let's do our substitution. We have 3 in brackets 1 minus minus 2 to be squared, all over 1 in brackets minus minus 2 in brackets. So now I know that there are secret brackets around the top and bottom of my fraction, so I need to simplify what's in brackets first. So I have 3 by 1 minus 2 by minus 2 is going to give me plus 4. So minus 2 squared means minus 2 multiplied by minus 2 will give me plus 4 all over, and I have multiply to do on the bottom, so 1 minus by minus is plus 2. So I get multiply to do next is 3 minus 4 all over, I can do my addition on the bottom is 3, and 3 minus 4 is minus 1 all over 3. So I get minus a third. So we can see the different parts and pieces of our variables and constants and the rules we have.